Okay, in this example, we're going to be working with a number of different functions. One's going to be the variance function, another one's going to be the index, max, or match, and then your all too familiar min function. And what we're going to be doing here is analyze a number of different machines. So let's just say what we're looking at here is a factory that manufactures soap powder. How original, right? And we have about 12 or 14 different lines that we can fill soap in. All right, so there's like 14 different machines that do this filling process. And we're just getting started. Things are really kind of haywire. But we're looking to run some tests as to how well they fill the boxes up. And it seems like when we look at this first one with machine 1 during our first test, here are the variant. I don't want to say variances, but these are what was thrown into the box. It could be ounces of soap, it could be pounds of soap, whatever it is, but that's what we got. So whatever the settings were on the machine to fill the boxes, and let's just say that was in pounds, then what we're looking at here is a wide spread of how much they're putting in there. I just made it really off the wall here just to kind of prove a point here. But that would be like the first test that they did, all right? The second test, oh man, I mean, especially with this machine 1, that went from 2.6 is down to 1.5. So again, I don't know what the settings were on the machine itself for each of the, or on the machines. They'd be all the same, but they got all these different numbers in there. It might be a few repeats, but overall, they're pretty varied. Same thing with the third time we did the test and the fourth time. Okay, so what we need to do is figure out, after the 4 tests, which machine has the lowest variance. In other words, if we're kind of looking at this as a wave going up and down, and we're looking at, like, let's say at machine number 5, we're going from 2.7 down to 1.2, up a little bit to 1.7, way up to 2.7 again. That's pretty varied there. Look at any of these other ones, all right? Which one would you say is the most consistent? I mean, when you look at the numbers, which line here, which machine has 4 numbers that are closest to each other? All right. Now, unless you're just a mathematical whiz where you can just kind of look at this like a paragraph of text and boom, know what it is, this is not going to be an easy task. So what we're going to do is put a formula in, okay, and the formula is called VAR.S. And what it will do is we'll look at the 4 and give us that variance, that spread. So if they end up being even, I mean, if these all were the same numbers, then you'd have a certain variance versus back and forth. Then I'll show you when we get done here with all this. But again, so what we'll do is we're going to start out over here first of all and putting in the function. So we'll do equal VAR, and we're going to do VAR sample. We're using the sample versus the population because we don't feel we have a large enough sampling. We didn't do enough tests, we feel, all right? So this way would be better. It estimates it based on a sample, right? Versus this would be more if you did 150 tests, all right, and you were looking at that. So we're going to go with the S. We'll double click that, all right, and then all you really have to do is select the range, just like that. We enter that in, we get 0.27. Go ahead and we copy that down, and there we go. Now, give you an example. If we had, let's say this was the 2 here, and I'm just going to go ahead and I'm going to copy this all the way across, just like that. That's going to give me 2 all the way across. The variance then, meaning how it varies from one number to the next, to the next, to the next, 0. That's what I'm talking about. So, given our eyeballs probably can't really figure this out, can't conclude that, can't really figure that out. We let that variance one take it for us. And you look at this and you say, well, which one is it? And I would say, looking at the numbers here really quick, that it looks like this one is the lowest variance. In other words, this has the most consistency. Well, if you look at it, especially here, 1.8, 1.6, 1.7, anything else, I mean, they're all over the place. See? So that's how you look at it. If you need to look at this as a percentage, you can always just kind of select the range like that. Go back up into your Home tab, hit the percentage button, maybe give yourself an extra decimal in there, and that might make it easier for you to see. Here, 9.7%. All right, so a lot easier to see. Now, aside from that, we want to be able to have it where when it does figure out which machine it is, in this case it would be this one here, machine 10, I actually want to see the machine's name appear here. I mean, even though it's pretty easy just to, especially when we switched it to percentage to be able to pick it out, might be, kind of neat to just see which one that is. So what we'll do then is we're going to put another formula in here. It's a little long. I don't expect you to remember it. If anything, if you ever need to do this, look up the video, look up the example that maybe you downloaded, from here, from one of those tabs on the side there, and kind of go from there. And you can open that up at any time. So in this case, we'll type in equal. We'll type in IN for index, okay? And we want to go from basically all the machine names. So we're going to go from A3 all the way down to 15, just like that. Then a comma, and then MA for match. So we double click on the match. And then we do MI for min. Double click onto that. And here we're going to go from F3. So these are going to be our variances here. So from F3 down to F15. All right. Close that off. Put a comma in there. And then we're going to select again F3 through F15. Okay. And then we're going to put another comma. And then a 0 for exact match. And then we'll go ahead and we'll close off the parentheses. So we're going to balance it off. Looks like we need 2 of them there. We'll enter that in. And there it goes, machine 10. We got these green guys popping up, letting us know something. Well, we're not wrong with our calculation, so we'll just go and select them all like this. Go to the little smart tag there. It says it's an unprotected cell. It says, it probably should be protected. It does that once in a while. Certain functions that you do, it wants you to protect those cells. That's in another set of videos, but at this point, we don't feel the need to do that. So we'll just tell it to ignore the error. And there we go. So there we have it. So hopefully this might come in handy for any of you in the future. It's a great way of looking at how one number changes compared to another, to the next, to see which rows change the least, right? They have a less up and down action, right? And you can do that with the VAR. You could also have this flip the other way. It could be where you're maybe measuring this and trying to do the variance on that to see which one of these 4 tests is the best. You probably wouldn't want to do that. That doesn't make much sense there, but you can do it either horizontally or vertically. So it works out pretty nicely. So hopefully you like this, and I appreciate you watching the video. Take care.